Hi everyone, we're going to take class notes on 8-6, which it says solving and graphing, but all we're going to do here is solve radical equations, and today is April 21st. What's a radical equation? It's an equation that has a variable in the root part of your problem. So as part of the radicand, you see a variable. And we have a power rule for solving these equations. It says if both sides of an equation are raised to the same power, all solutions of the original equations are also solutions of the new equation. So that's just saying once we isolate a root, we can take to the power on both sides of an equation. So any power that we want, squared, cube, fourth power, any power. All right, so that's the vocab that you should be writing down. Here are some steps. To solve these, you want to isolate the radical. Now, some problems will have two, so isolate one of them. Pick one, isolate it. That means get it alone. Apply the power rule. Raise to the power that you need to get rid of the root. If it's a square root, square both sides. If it's a cube root, cube both sides. Then you solve, and we have to check for extraneous here, especially when we're dealing with square roots, because we can't have a negative underneath a square root or a fourth root. Even index, no negatives. And we are going to go ahead and start our process of solving. So our first radical equation that we need to solve looks like this. So my first step is going to be to isolate the root by subtracting over the 3. Then I'm going to get root 5x minus 1 equals x minus 3. Because I have two terms here, I need to, when I go to use power rule, which is step 2, I need to think of that as a quantity. So when I square to get rid of the root on the left side, I need to square this quantity of x minus 3. Squared and root, easy, 5x minus 1. We lose that part of it. The squared and the root cancel out. This part, we can use the pattern. So although it's more work, it should still be easy for us. Square the first, 2 times the first times the last, and the last squared. Now I recognize I have a quadratic, no radical equation anymore. So I've changed the equation into a quadratic, and I'm going to solve that using factoring. I'm saying factoring because I see that I have linear terms. So I'm going to subtract over the 5x and add over the 1. 0 equals x squared minus 11x plus 10. So I'm going to factor box and use x and x. I'm going to use negative 10 and negative 1. Those multiply to give me a positive 10, checking my diagonals, multiplying, and then adding those together to get negative 11x. So my factors are x minus 10 and x minus 1. When I solve, I get 10. And I get 1. So if I were to check, a 1 here, good. A 1 here, square root of 4, 2. Plug in a 1. Square root of 4 is 2. 2 plus 3 is 5. Does that equal 1? No, then this would be extraneous. So maybe just showing that quickly. So here are my checks. I'm going to go ahead and check x equals 1. We said square root of 4 plus 3, does that equal 1? And the answer is no. So this one becomes extraneous. Checking 10. We have the square root of 50 minus 1 is 49. Plus 3, does that equal 10? Well, yes, 7 plus 3 is 10. So this is the answer that works. All right, moving on to the second equation, second equation, solving the second equation. Again, this is a problem where we have two roots, isolate a root. So I'm just going to get this one alone by adding this one over to the other side. What's nice about this one is that there's just a 0 over here. So I will just have a root equal to a root. Adding 0 with a root is just going to give us our root. So we have 3x plus 2. Equals the square root of 2x plus 7. So when we have a root equal to a root, we can just say it doesn't really matter which one you focus on. They're both isolated. We're ready to do our power, raised to the power, which makes the root cancel, leaving me with 3x plus 2 and 2x plus 7. Then I have created a linear equation. So I solve my linear and get x equals 5. And then checking to make sure 5 works in that original. So in all of the places where I see an x, I put a 5. So 15 plus 2 is root 17 minus the square root of 10 plus 7, which is 17. Does that equal 0? Yes, 1 root 17 minus 1 root 17 is 0 root 17, which is equal to 0. So 5 is our solution. Next example, 2 roots in the problem, but this isn't a 0. There's a 1. So when I go to move this over, this is a lot. And I'm not changing any signs underneath. I'm just moving the root x plus 1 by subtracting it over. There's a lot more work we're going to have to do here in this one, and you'll see. So I've decided to isolate the 2x plus 3. And on this side, I have a quantity. So I have to think of that as a quantity. Those are not like we can't put those together. This is what I isolated. This is what I'm going to raise to the power. What I do to one side, I do to the other. That's going to leave me with 2x plus 3. I have to pattern this side. So I have to square the first. 2 times the first times the last is negative 2 root x plus 1. Then I'm going to square the last. When I square this, I get a positive x plus 1. So hopefully that's clear, but now what do I have? I now have a new radical equation, so I want to isolate this. 1 plus 1, maybe I should just, I'm going to do that on this side. I'm going to keep this. Actually, I'm going to subtract over the x. So I'm going to go ahead and do that. And I'm going to get x plus 3 equals 1 plus this 1 is 2 minus 2 root x plus 1. Get a minus the 2. And then I'm going to get x plus 1 equals negative 2 root x plus 1. Now I could divide the negative 2, but then I have fractions over here. So I think I'm going to leave that negative 2 there and square. But when I go ahead to square both sides to get rid of this root, I have to think of this and make sure I square that negative 2 as well. So squaring to get rid of the root. So I'm going to get, my pattern says x squared, 2 times the first times the last, plus 2x plus 1 equals, and now squaring this is going to give me a negative 2 squared is 4, and then this root squared is just x plus 1. I'm going to move over here to finish this problem. So I have x squared plus 2x plus 1 equals 4x plus 4. So I'm distributing. And now I'm going to move these over. They're quadratic, so I'm going to subtract over the 4x and subtract over the 4 to get x squared minus 2x minus 3 equals 0. And I'm going to factor box. I'm going to squeeze my factor box in here. X squared minus 3, x and x. I'm going to use negative 3 and 1. That's going to match my middle term. So I get x minus 3 and x plus 1 equal to 0, which means my solutions are 3 and negative 1. And so now I need to check those back into the original. So checking 3. Let's see. 3 here is going to be 6 square root 9. 3 here is going to be plus square root 4. And then does that equal 1? And this is checking 3. And so I end up with 3 plus 2, which does not equal 1. So 3 is extraneous, get rid of that. And now I'm going to check x equals negative 1. That's a negative 2. So that would be 1, square root of 1, plus negative 1 plus 1 is the square root of 0. Does that equal 1? 1 plus 0 equals 1. This works. That does not. Our solution is negative 1. Quickly, you'll see two problems like this on homework where you need to solve for L. Well, the root's isolated, square both sides. I get z squared equals L over C. And then to get the L alone, I multiply both sides by C. Sorry, the paper's being funny. So then I get C times Z squared equals L. So again, get rid of the root. Division's going on. To get the L alone, we multiply both sides by C. Final answer, C times Z squared equals L. All right, that's it for today. Bye, everyone. Good luck with those.